You walk into a clothing store and pay $50 for a shirt. You take it home, you wear it, and from your perspective, the transaction seems simple. You gave the store $50. The store gave you a shirt. But there is a strange part of that transaction that most people never think about. The factory that actually made the shirt never received that $50. Not even close. By the time that shirt reaches the rack, money has already been divided between fabric, labor, packaging, shipping, warehouses, marketing, distribution, retail, and all the businesses sitting between the factory and the customer. So if the factory only gets a small piece of the final price, how does manufacturing clothing make anyone rich? And this is where the clothing business becomes much more interesting. Because the factory is not really trying to make a fortune from one shirt. It is trying to make thousands of nearly identical shirts efficiently enough that a tiny margin on each one becomes meaningful at enormous volume. That is the real business. And once you understand that, the entire clothing supply chain starts to look different. The factory doesn't own the brand. The name printed on your shirt is usually not the name of the factory that made it. A clothing brand might design the product, choose the fabric, decide the colors, create the marketing campaign, and sell the finished garment to customers. But it may never own the machines that actually produce it. Instead, the brand sends the production order to an independent manufacturer. The factory receives the design, the fabric requirements, the quantity, the quality standards, and the deadline. Then the factory has to take all of those instructions and turn them into thousands of identical garments. That sounds straightforward, but the factory is solving a difficult production problem. How much fabric will this order require? How many workers are needed? How much sewing time will each garment take? How much will the thread cost? What about labels, packaging, quality control, machine time, electricity, factory overhead? And how much profit is left after all of that? The brand does not want a factory that simply says, "We can make the shirt." It wants a factory that can make the exact shirt, in the exact quantity, at the promised quality, for the agreed price, and deliver it on time. That is what the factory is really selling. Not just shirts. Production capacity. One factory can serve many brands. The same factory may manufacture clothing for several different buyers. This means the brand on your shirt and the factory behind it can be completely separate businesses. One week, a production line might be making a basic T-shirt for one customer. The next week, the same machines might be producing garments for another brand. The machines do not care whose logo eventually appears on the finished product. They care about the production specifications. And that creates an unusual business model. A factory can build expertise and infrastructure once, then use that capacity to serve many different customers. That is one reason manufacturing can scale. The factory does not need to invent a new business every time a new brand arrives. It needs to learn how to turn customer orders into efficient production. Where does a factory get work? It starts with an order. A brand or buyer sends a manufacturer a design. Then come the technical requirements. Fabric type, quantity, color, measurements, quality standards, packaging requirements, delivery date. The factory studies the garment and estimates what it will cost to produce. Then it creates a price. If the buyer accepts that price, the order is placed. Only then does the factory move from design to mass production. And that is where the economics of volume begin. Why factories love big orders. Imagine asking a factory to make one shirt. That first shirt requires much more preparation than the finished piece makes obvious. Someone has to study the design. Patterns had to be prepared. Fabric has to be organized. Machines had to be configured. Workers had to understand the sequence. Quality requirements had to be established. The production line has to be prepared. All of that happens before the shirt becomes a finished product. Now make 1,000 shirts. The setup is still mostly the same. The difference is that the setup cost is now divided across 1,000 garments. Make 10,000. Even better. Make 100,000. Now the economics change dramatically. The factory can perform the same basic production sequence over and over. Workers stay focused on specific operations. Machines remain active. Materials move continuously. The production line does not have to stop every few minutes and reinvent itself. And the average cost per shirt can fall. That is the first major secret of clothing manufacturing. The factory is not optimizing one shirt. It is optimizing the production run. The power of tiny savings. Now imagine the order grows to 100,000 shirts. The factory still needs fabric for every shirt, labor for every shirt, thread, labels, packaging, but many production costs are spread across the entire order. And once you're manufacturing at this scale, tiny savings become real money. Save 10 cents on one shirt. That sounds insignificant, but across 100,000 shirts, it becomes $10,000. And that is where manufacturing economics become fascinating. A factory does not necessarily need one revolutionary breakthrough. It can improve profitability by saving a few cents here, a few seconds there, a little less fabric waste, a little faster sewing operation, a slightly cheaper packaging method, a better production layout, a lower defect rate. Each improvement looks almost meaningless when viewed individually. But the factory repeats those improvements thousands of times. And repetition is where the money appears. What does the factory get from a $50 shirt? Now let's go back to that shirt you bought for $50. The factory might receive only a fraction of that retail price. For this simplified example, imagine the manufacturer charges around $7 for the finished garment. That $7 is not $7 of profit. It has to cover the things that actually go into producing the shirt. Fabric, labor, thread, labels, packaging, quality control, factory overhead, electricity, equipment, supervision, maintenance, and whatever other costs are required to keep the production line running. Only after those costs are covered does the factory have a margin. So when you look at a $50 shirt hanging in a store, that $50 tells you almost nothing about what the manufacturer actually earns. The customer sees a $50 price. The factory sees a production margin. Those are two completely different numbers. And now we can follow the money. First comes the fabric. Before a shirt reaches a sewing machine, the factory has to buy the raw material. Fabric is one of the most important costs in garment manufacturing. A large order may require thousands of yards of material. And every shirt consumes some of it. That means even a small change in fabric price gets multiplied across the entire production run. Cotton prices move. Synthetic fiber costs can change. Energy markets affect raw material production. Transportation can change supplier costs. And supply conditions can shift what a manufacturer pays. Imagine the factory agreed to a production price with the brand months ago. Then fabric costs rise. If the contract price does not change, the factory may have to absorb much of that increase. And suddenly a change that looks tiny on one shirt becomes a major financial problem across the entire order. A difference of 20 cents per shirt across 100,000 shirts becomes $20,000 in additional cost. The factory still has to produce the same garments. But the margin is now smaller. That is why manufacturers watch material prices so closely. The factory owns the whole roll. And paying for fabric is only half the problem. The factory also has to use it efficiently. Before cutting begins, garment pieces are arranged across long layers of fabric. It is basically a puzzle. The goal is to fit as many useful pieces into the available material as possible. Sleeves can be placed beside body panels. Smaller pieces can fill gaps. Patterns can be rotated and rearranged. The tighter the layout, the more garments can be cut from the same roll. And that matters because the factory already paid for the entire roll. If some of that fabric becomes unusable waste, the factory still paid for it. One scrap may not look important. A few scraps may seem irrelevant. But repeat that waste across 100,000 shirts and suddenly the factory is throwing away real money. This is why pattern efficiency matters. The factory wants to turn as much purchased fabric as possible into sellable clothing. More usable fabric per roll means lower material cost per garment. And when margins are thin, even small improvements matter. Then the sewing line starts. Once the fabric is cut, the pieces enter production. But one worker usually does not make the entire shirt. Instead, the factory breaks the garment into smaller operations. One worker joins the shoulders. Another attaches sleeves. Another closes the sides. Another finishes the collar. And another performs a final operation. The shirt moves from station to station. Each worker performs a specific task. And the garment becomes more complete as it moves through the line. This is the assembly line principle. It allows the factory to produce thousands of similar garments efficiently because each worker becomes highly familiar with a specific operation. The goal is not to have one person making one shirt from beginning to end. The goal is to make the entire production line flow. 5 seconds can matter. And this is where manufacturing gets strange. A few seconds can become expensive. Suppose one operation takes 5 seconds longer than planned. 5 seconds does not sound important. But that delay repeats on every shirt passing through that station. Across hundreds of garments, those seconds become minutes. Across thousands, they become hours. And because one station feeds the next, a slow operation can reduce the output of the entire line. That is why factory management pays so much attention to workflow. Where workers stand, how materials move, how many seconds each operation takes. Whether machines are waiting, whether workers are waiting, whether finished pieces pile up between stations. The factory is not simply trying to make shirts. It is trying to keep the production system moving. Every station has to feed the next. Imagine one worker finishing sleeves faster than the next station can handle them. Now pieces begin piling up. The first worker may have nothing else to do. The next worker becomes a bottleneck. And eventually the entire line slows down. Now reverse the problem. Suppose one station is too slow. Workers behind it wait for components. Machines sit idle. Production falls. The factory does not need every worker to move as fast as physically possible. It needs the entire system to move at a balanced rate. This is why production engineering matters. One unusually slow operation can affect thousands of finished garments. Then come the tiny materials. Fabric may be the biggest material cost. But it is not the only one. Every garment may require thread, buttons, zippers, labels, tags, packaging, and other small components. Each item seems cheap individually. A few cents, maybe less. But remember how this factory works. A few cents multiplied across tens of thousands of garments becomes real money. A small increase in packaging cost. A small increase in trim cost. A small increase in labels. The factory pays all of it. That is why manufacturers track tiny costs that consumers never notice. The customer sees a shirt. The factory sees hundreds of individual cost components. A finished shirt isn't finished. Now the shirt is sewn. But the factory is not done. Before the shipment leaves, the garments need to be inspected. Workers check for bad stitching, wrong measurements, stains, damaged fabric, incorrect labels, other defects. Quality control takes time. It takes workers. It takes space. And it costs money. But skipping it can be even more expensive. A factory that ships defective garments risks customer complaints, returns, rejected orders, penalties, and damaged relationships. So the factory has to find the balance between speed and quality. Produce quickly, but produce correctly. Defects are expensive. Imagine a shirt fails inspection. Maybe the stitching is wrong. If the problem is small, the factory may repair it and inspect the garment again. That takes additional labor, additional time, and additional machine capacity. But what if the defect is serious? The garment may need to be remade, or rejected completely. The factory already bought the fabric, already paid the worker, already used machine time, already consumed electricity, already used factory capacity, but now there is no sellable output. That is why defects can destroy margins. The factory is paying to produce something that cannot generate revenue. The more defective garments it creates, the more expensive the order becomes. What does one shirt actually cost? Now we can finally build the real production cost. Start with fabric. Add sewing labor. Add thread, labels, packaging, quality control, factory overhead, equipment, maintenance, supervision, utilities. Nothing here looks enormous by itself. But together, these expenses create the real cost of manufacturing the shirt. And the difference between that cost and the factory's selling price becomes the margin. That sounds simple, but estimating that cost accurately is one of the most important skills inside the factory business. Pricing the order. Before accepting an order, the factory estimates what it will actually cost. How much fabric? How much labor? How much production time? How much packaging? How much quality control? How much overhead? Then it adds a margin. And that becomes the quoted factory price. But now imagine you make a mistake. Maybe the fabric estimate was too low. Maybe the sewing time was underestimated. Maybe defect rates are higher than expected. Maybe a supplier raises prices. Maybe the order takes longer than planned. A tiny error gets multiplied across the entire order. That means factory pricing is not just about guessing what the market will pay. It is about predicting the real cost of production. $7 is not profit. This is where people misunderstand factory economics. A $7 factory price does not mean the factory makes $7. Most of that money immediately disappears into production costs. Fabric, labor, trims, packaging, quality control, overhead. Only after all of those are paid can the factory see what is left. And that may be a surprisingly small amount. Which means the factory does not necessarily make much money on one shirt. Its economics depend on repetition. A small margin, multiplied by a huge number of garments. That is the game. Volume can beat price. This is why an expensive garment is not automatically more attractive to a factory. Imagine one complicated jacket. It may have a high factory price. But suppose the buyer orders only a small quantity. Now imagine a simple shirt. The margin per garment is smaller. But the factory produces 100,000 of them. The second order may create far more total profit. The factory is not asking only, how much do I make on this garment? It is also asking, how many can I produce? How efficiently can I produce them? And how consistently can I keep that production line running? For manufacturing, volume can be more powerful than price. Fixed costs don't disappear. And not every factory cost rises with production. Some costs increase every time another shirt is produced. Fabric, thread, packaging, direct labor. But other costs remain. The building still exists. Machines still need maintenance. Supervisors still need to be paid. Equipment still occupies space. Utilities continue. These are fixed or semi-fixed costs. And this creates another important part of factory economics. The more shirts the factory produces, the more units those fixed costs can be spread across. That can lower the average cost of each garment. But when production slows, the opposite happens. The idle factory problem. Imagine a factory running at full capacity. Machines are operating, workers are busy, materials are moving, orders are shipping. Now imagine half the orders disappear. The factory buys less material. Some direct labor falls. Some variable costs decrease. But the building is still there. The machines are still there. Maintenance still exists. Supervisors still have to be paid. The factory still has operating expenses. With fewer shirts coming off the line, those costs are spread across fewer units. And suddenly each garment costs more to produce. That is why an idle factory can lose money surprisingly quickly. The factory is paying for capacity, it is not monetizing. Machine utilization is everything. Think about a sewing machine sitting unused. It still occupies space. It still represents capital. It still required maintenance. It still belongs to the factory. But while it is idle, it is not generating sellable output. Now put an order in front of it. Keep it productive for more of the day. The same machine can support more garments. The cost of owning that machine is spread across more production. That is machine utilization. And it is one of the hidden engines of manufacturing profitability. The factory wants its expensive infrastructure doing productive work. But there is a limit. Push utilization too far and the system can become unstable. Machines break. Workers get overloaded. Maintenance gets postponed. Quality falls. And production slows. So the goal is not maximum activity at any cost. The goal is profitable utilization. Faster isn't always better. Once a factory is busy, speed becomes another lever. If the same workers and machines can produce more sellable garments in the same amount of time, the factory can spread fixed costs across more units. That sounds like an obvious win. But speed is only valuable when quality stays intact. Producing defective shirts faster is not efficiency. It is faster waste. So the best factories focus on useful output. More sellable garments. Less wasted fabric. Less waiting. Fewer defects. Smoother production. Better worker coordination. The factory is trying to get more value from the same resources. Manufacturing efficiency is a system. This is why efficiency is bigger than sewing speed. It includes fabric utilization, worker organization, machine uptime, production balance, quality control, material flow, waiting time, rework, and every small interruption that prevents the factory from producing finished garments. A factory can save a little fabric, a little labor, a little machine time, a little packaging cost, a little quality control time. Individually, none of these changes looks impressive. But manufacturing is built on repetition. If you save 5 cents on one shirt, almost nobody notices. Across 100,000 shirts, that becomes $5,000. Save another 3 cents in fabric, 2 cents in packaging, A little labor time. Now the savings begin stacking. The factory does not need one huge breakthrough. It needs hundreds of tiny improvements working together. The factory has one big advantage. And that advantage is scale. A factory that produces 1,000 shirts and a factory that produces 100,000 shirts may perform many of the same preparation steps. Samples, patterns, machine setup, worker organization, quality requirements, production planning, but the larger order spreads those costs over far more garments. It may also allow the factory to buy materials in larger quantities. Keep machines running longer. Keep workers on familiar operations. Reduce changeovers, and improve average production cost. That is why scale matters so much in clothing manufacturing. The shirt leaves the factory. Now let's follow the shirt again. The manufacturer produces it. The factory might charge the buyer around $7. And then the shirt leaves. But the $7 is not the end of the economic story. It is the beginning of another chain. The garment still needs to be shipped, imported, stored, distributed, marketed, placed in a store or sold online, and supported by a business that has its own employees, rent, technology, returns, inventory risk and profit requirements. That is how a $7 factory product can eventually become a $50 retail product. Why does a $7 shirt become $50? Because the shirt is not moving directly from a sewing machine to your closet. It moves through a supply chain. Freight companies get paid. Ports get paid. Importers may pay duties and fees. Warehouses charge for storage. Workers handle the inventory. Brands spend money creating demand. Retailers pay rent and employees. Marketing costs money. Returns cost money. Unsold inventory creates risk. And every business in that chain needs some margin. So the difference between $7 and $50 is not simply profit. It is the economics of an entire system. Shipping is part of the price. A clothing factory may be thousands of miles away from the customer. That means the shirt may travel by truck, then to a port, then into a shipping container, across an ocean, then through another port, then onto another truck, then into a warehouse, and eventually toward the store. Every step involves fuel, workers, equipment, infrastructure, and time. Spread across thousands of shirts, the shipping cost per garment may look small. But across an enormous production order, it becomes a significant expense. And there is another hidden cost. Inventory tied up in transit. The shirt cannot be sold while it is still on the ship. Crossing borders adds more costs. The journey can also involve customs duties, taxes, clearance fees, documentation, inspection. Depending on the country and product, those charges can materially increase the landed cost. And these expenses happen after the factory has already completed production. The factory may have already been paid for manufacturing, but the shirt is still getting more expensive before it ever reaches the store. That is why the factory price is only one component of the final economics. The warehouse gets involved. Once the garments arrive, they need somewhere to go. A warehouse stores them, but storage is not free. The business pays for space. Workers receive cartons. Forklifts move boxes. Inventory systems track every product. And every box consumes capacity until somebody buys what is inside. A shirt sitting on a warehouse shelf is not earning money. But it is still consuming money. That is the hidden cost of inventory. The brand has its own business. And now the brand gets involved again. The brand may have designers, product developers, merchandising teams, supply chain employees, customer service, technology, offices, returns processing, and all of those expenses have to be recovered through product sales. That means the brand's economics are different from the factory's. The factory focuses on producing efficiently. The brand focuses on creating products people want and creating enough demand to sell them. Manufacturing creates the product. Branding helps create the market. Then comes marketing. And this is where the economics can become surprising. A brand can spend enormous amounts of money getting you to notice a shirt. Photography, advertising, creators, influencers, store displays, promotions, social media, search advertising, campaigns, all of it costs money. A factory can make a perfectly manufactured shirt. But if customers never see it, the factory's efficiency means nothing to the retailer or brand. Manufacturing creates supply, marketing creates demand, and the clothing business needs both. Retail needs a margin. Now the shirt reaches the store. The retailer has its own expenses. employees, rent, lighting, payment processing, stockroom space, returns, technology, security, unsold inventory, and more. The retailer cannot simply sell the shirt for whatever price it paid. It needs a margin large enough to cover those costs and compensate it for taking the inventory risk. That is another reason the retail price can be so much higher than the factory price. But the $50 price isn't guaranteed. And here comes another important risk. The shirt may not sell for $50. Maybe customers do not like the color. Maybe the trend changes. Maybe the season ends. Maybe the retailer ordered too many. Maybe another product performs better. Now the retailer has a decision. Keep the price high and hope the inventory sells. Or reduce the price and recover some of the money. The shirt might go from $50 to $40. Then $35. Maybe lower. But the original costs do not disappear. The shirt was still manufactured. Still shipped. Still imported. Still stored. Still marketed. Still placed in the store. Discounting changes the selling price. It does not rewind the supply chain. Unsold inventory is dangerous. And this is where clothing becomes a risky business. A shirt that never sells is a strange asset. It contains real costs: fabric, labor, shipping, duties, warehousing, marketing, retail space, but it does not produce revenue. It may eventually be discounted heavily. It may be returned. It may be moved to another market. Or it may never sell at all. Multiply that problem across thousands of garments and a collection that looked profitable on paper can become a serious loss. That is why inventory forecasting is so important. The clothing business is not just about making products. It is about making the right products in the right quantities at the right time. Why are factories so far away? Now we get to another question. Why is so much clothing manufactured far away from the people who eventually buy it? Lower labor costs are part of the answer. But they are not the entire answer. Some manufacturing regions have been building clothing ecosystems for decades. Fabric mills, trim suppliers, skilled workers, machine technicians, warehouses, logistics companies, specialized factories, all concentrated near one another. That network matters. A factory is not operating alone. It is operating inside an industrial ecosystem. Cheap labor isn't enough. Imagine two factories. Factory A has cheaper labor. But the fabric has to travel a long distance. The trims arrive late. Production gets interrupted. Quality problems create rework. Shipments are delayed. Factory B pays slightly higher wages. But suppliers are nearby. Workers are experienced. Materials arrive quickly. Production runs smoothly. Quality is consistent. And deliveries happen on time. Which factory is actually cheaper? The answer may be Factory B. That is why brands do not simply choose the factory with the lowest wage bill. They care about total landed cost, reliability, quality, speed, and consistency. Supplier networks create power. A clothing factory depends on other businesses. Fabric suppliers, thread suppliers, button manufacturers, zippers, labels, packaging, machine parts, transportation. When those suppliers are nearby, problems can be solved faster. Materials can arrive more quickly. Shortages can be corrected. Production spends less time waiting. And that creates an advantage that is difficult for a new factory somewhere else to reproduce immediately. The supplier network itself becomes part of the competitive advantage. Manufacturing clusters matter. This helps explain why factories cluster together. Once a region develops fabric mills, trim suppliers, workers, technicians, warehouses and logistics companies, more manufacturers have a reason to locate there. And once more factories arrive, even more suppliers appear. The ecosystem reinforces itself. Factories can find skilled labor. Suppliers find customers. Workers find employers. Logistics companies find steady volume. The entire region becomes more efficient at producing clothing. This is industrial clustering, and it can be more powerful than cheap land or cheap labor alone. But distance has a cost. There is a trade-off. The farther a factory is from the customer, the farther every garment has to travel. That means longer shipping times, more inventory in transit, more uncertainty, and less flexibility. A factory thousands of miles away may produce the shirt cheaply. But if the brand suddenly discovers that one style is selling much faster than expected, getting another shipment can take weeks. A closer manufacturer may cost more per garment, but it can respond faster. And speed has economic value. Sometimes speed beats cheap labor. Imagine a brand does not know how many shirts customers will actually buy. It could order a huge quantity from a distant factory at a low unit cost. Or it could produce a smaller quantity closer to the market, watch customer demand, and reorder quickly. The second option may cost more per shirt, but it reduces inventory risk. Less money is committed up front. Fewer garments remain unsold, and the brand can respond to real demand rather than guessing months in advance. In fast-moving fashion, that flexibility can be worth more than the lowest factory price. Delays cost more than money. Now imagine a factory misses a deadline. Fabric arrives late, production starts late, the shipment misses its scheduled departure. The container arrives late, and the clothing reaches stores after the demand peak has already passed. The factory invoice may not show the full cost of that mistake. But the brand feels it. Customers may have moved on. Promotional campaigns may have already ended. Stores may have missed the selling window. And now the brand may have to discount the product. A few days of delay can create costs across the entire supply chain. Repeat customers are valuable, and that is why factories love repeat customers. A new brand requires work, samples, negotiations, specifications, quality requirements, production planning, communication. The factory has to learn how the customer operates. A repeat customer is different. Much of the groundwork has already been completed. The factory knows the buyer. The buyer knows the factory. The production requirements are familiar. The quality expectations are established. And repeat orders can be easier to schedule. That predictability has economic value. Long-term relationships change the factory. Imagine a factory expecting regular orders from the same brand for years. Now management can plan ahead, reserve capacity, prepare materials, schedule workers, invest in equipment, train employees around recurring products. The factory has more confidence. It does not have to rebuild its customer base every month. And that stability can make the operation more efficient. The factory is no longer simply selling production. It is selling reliable long-term capacity. Large orders lower average cost. This takes us back to volume. A factory preparing an order for 1,000 shirts and one preparing 100,000 shirts may both need patterns, samples, setup, planning and supervision. But the larger order spreads those costs across dramatically more garments. The factory may also negotiate better material prices, run machines longer, avoid unnecessary changeovers, keep workers focused, and reduce average cost per garment. That is why the factory business rewards scale. Specialization makes factories better. Factories also tend to specialize. One may focus on basic T-shirts, another on denim, another on sportswear, another on technical jackets. Specialization creates learning. Workers become more experienced. Machines stay configured for familiar operations. Suppliers provide recurring materials. Production managers become better at solving the same category of problems. Over time, repetition can make the factory faster and more consistent. The factory gets better at the thing it does repeatedly. Different clothes create different problems. A basic T-shirt and a technical jacket may both be clothing. But they are completely different manufacturing systems. A T-shirt may use relatively few pieces and repetitive sewing operations. A jacket may require multiple layers, pockets, zippers, lining, reinforcement, more seams, more operations, more inspections, more opportunities for mistakes. That means the factory needs different workers, equipment and processes. Complexity has a cost. Design changes are expensive. Even changing a garment design can create new costs. New patterns, different fabric, different trims, new machine settings, new sewing operations, worker training, quality control adjustments, and line setup. The factory may need to stop, prepare, test, then restart. During that changeover, fewer garments are being produced, which means the factory is paying for time without generating the normal amount of output. That is why long runs of similar products can be so valuable. Small orders are expensive. This is another reason small production runs can cost more. The factory still has to prepare everything: samples, patterns, materials, machines, workers, quality requirements. But now those setup costs are spread across far fewer garments. And once the short order is finished, the line may have to change again. The more often the factory changes what it is producing, the more time it spends preparing instead of making sellable garments. Minimum order quantities. That is why factories often require minimum order quantities. The factory needs enough production volume to justify setup, enough garments to spread the preparation cost, enough revenue to make the order worthwhile. If a brand wants only a very small run, the factory may have little economic room to absorb all of the preparation and production costs. The minimum quantity protects the factory from spending heavily to produce an order that is too small to be profitable. What if the customer cancels? Now imagine the brand changes its mind. The factory may already have bought fabric, ordered custom labels, reserved production capacity, scheduled workers, prepared machines. Maybe thousands of garments are already finished. If the customer cancels, the factory is left holding costs that cannot easily be reversed. The buyer walked away. But the fabric was already purchased. The labor already happened. The factory time already disappeared. And the production capacity was already used. A seemingly profitable order can suddenly become a major risk. Inventory can trap cash. Every piece of inventory represents money already spent. Fabric sitting in storage. Trims waiting for production. Half-finished garments. Completed shirts waiting for shipment. All of them represent cash that is no longer available for other purposes. The factory still needs to pay employees, suppliers, electricity, rent, maintenance. The longer inventory sits, the longer that money remains trapped. And if the inventory cannot be sold, the problem gets worse. Cash flow can kill a profitable factory. This is one of the most important lessons in manufacturing. A factory can have profitable orders and still run short of cash. Why? Because expenses often happen before the final payment. The factory may buy fabric today, pay workers every week, pay electricity bills, pay suppliers, produce the garments, ship them, and only later receive the customer's full payment. If too much cash leaves the business before enough comes back, the factory can struggle to fund its next order. Profit tells you whether the business can make money. Cash flow tells you whether the business can survive the timing. And those are not the same thing. The cheapest factory doesn't always win. Now imagine 3 factories competing for the same order. One offers the lowest price. Another is slightly more expensive but has excellent quality. A third is slightly more expensive again but is known for reliable delivery. Which one does the brand choose? It depends on what the brand values. Because a cheap shirt that arrives late or has a high defect rate may actually cost more than a slightly more expensive shirt that arrives correctly and on time. Quality problems can create returns, rework, delays, complaints, lost sales, and damaged brand reputation. The cheapest factory price can become the most expensive decision. Reliability is a product. This is why factories are selling more than manufacturing. They are selling reliability. The ability to produce thousands of garments consistently. The ability to meet deadlines. The ability to maintain quality. The ability to solve problems. The ability to scale when the order gets larger. A brand wants confidence that the factory can deliver what it promised. That confidence has economic value. Automation changes the equation. Automation can also change factory economics. Not every sewing operation can be fully automated. Fabric is flexible. Garments move. And many processes still require skilled human handling. But factories can automate parts of the workflow. Fabric spreading, cutting, material movement, repetitive sewing, quality checking, inventory handling. These tools can reduce labor time and waste. But automation costs money. Machines require capital, maintenance, training, space, and utilization. That means automation becomes much more attractive when the factory has enough production volume to keep those systems busy. Unused capacity is an opportunity. Now imagine a factory has already paid for its building, its machines, its supervisors, its basic infrastructure. But part of the production line is sitting unused. Then a new order arrives. The factory still has to buy fabric, pay direct labor, use packaging, and consume production materials. But much of the fixed infrastructure is already there. That means the new order may contribute more profit than you would expect. Because the factory is monetizing capacity it already paid for. This is another reason utilization matters so much. Scale changes everything again. Now compare 1,000 shirts with 100,000. The larger order can spread setup costs across a much bigger production base. It may qualify for better material prices, allow longer production runs, reduce machine changeovers, improve labor productivity, and keep expensive equipment productive for longer. The factory may spend far more money in total, but the average cost per garment can fall. That is the paradox of manufacturing. More production can mean more total spending and lower cost per unit at the same time. So who actually makes money? Now we can answer the original question. Who makes money from your clothes? The answer is not simply the factory. And it is not simply the brand. A shirt moves through an entire network of businesses. The factory earns a manufacturing margin. Shipping companies get paid. Warehouses get paid. Importers may get paid. The brand pays for design and marketing. Retailers pay employees and rent. And each business tries to keep a margin for itself. That $50 shirt is not one company's revenue disappearing into one huge profit pool. It is an economic chain. The factory's real profit engine. So where does the factory's profit actually come from? Usually not from charging a huge amount for one shirt. It comes from controlling thousands of tiny costs. Better fabric utilization, faster production, fewer defects, lower packaging costs, more efficient labor, higher machine utilization, better supplier pricing, fewer delays, more repeat orders, and longer production runs. Each improvement may save only a few cents. But the factory does not make one shirt. It makes thousands, sometimes hundreds of thousands, sometimes millions. That is where the economics become powerful. The factory is selling capacity. And this is the new way to look at the whole business. The factory is not really selling shirts. The factory is selling the ability to turn raw materials into thousands of consistent garments at a predictable cost and on a predictable schedule. A brand buys that capacity. The factory fills it. Workers and machines turn it into output. And the factory gets paid for making the system work. That means the real asset is not simply the sewing machine. It is the entire production system. The workers, the machines, the supplier network, the management, the quality process, the logistics relationships, the customer relationships, and the accumulated knowledge of how to make a specific type of garment efficiently. That is why repeat orders matter. A repeat order is more valuable than it looks. The factory already understands the garment. The workers already know the process. The machines are already configured. The quality requirements are familiar. The supplier relationships already exist. The buyer already trusts the factory. The factory can often move faster with less uncertainty. That means a repeat customer can generate more than revenue. It can generate predictability. And predictable production makes everything easier. The clothing business is a volume game. The factory does not need to make $20 on every shirt. It needs a margin that survives the entire production process. Then it needs that margin repeated. Again, again, again. That is why one simple shirt can be economically more attractive than a complicated garment. The simpler product may have a smaller margin. But it can move through the line faster. Use fewer materials. Create fewer defects. Require less setup. And be ordered in massive quantities. A small margin on enormous volume can beat a large margin on tiny volume. And the retail price can mislead you. So when you see a shirt selling for $50, your instinct may be to ask, how much did the factory make? But that is not the most useful question. The better question is, how many shirts did the factory make, and how efficiently did it make them? Because the retail price is almost irrelevant to the factory's profit if the factory has already agreed to its production price. The factory is focused on cost control, volume, capacity, quality, and utilization. That is its game. The entire supply chain is a business. And that is why the $50 shirt is actually several businesses connected together. The factory makes it. The logistics network moves it. Customs and importers bring it across borders. Warehouses store it. Brands create demand. Retailers sell it. Customers decide whether it was worth the price. And every link has costs. Every link carries risk. Every link needs enough margin to keep operating. The shirt may look like one simple object. The economics behind it are anything but simple. The final lesson. So the next time you walk into a clothing store and see a $50 shirt, remember what that price really represents. The factory may receive only a small fraction. And its actual profit may be even smaller. But that does not mean the factory business is unattractive. It means the game is different. The factory wins by producing efficiently. By reducing waste. By keeping machines productive. By controlling labor time. by buying materials intelligently, by maintaining quality, by delivering on schedule, by securing repeat customers, and by turning tiny savings into meaningful money through enormous volume. The factory is not trying to become rich from one shirt. It is building a system where one small margin gets repeated thousands of times. And that changes how you should look at manufacturing. The real product is not the shirt. The real product is the factory's ability to produce that shirt again. And again. And again. At a cost low enough to make the entire system work. That is why factories care about seconds, cents, fabric scraps, machine utilization, defect rates, supplier relationships, order sizes, repeat customers, and cash flow, because every one of those tiny details determines whether a production line is merely busy or genuinely profitable. So when you see a $50 shirt hanging on a rack, remember, the customer sees fashion, the brand sees a product, the retailer sees inventory, but the factory sees something very different. It sees a production run, thousands of garments, thousands of small decisions, thousands of opportunities to save a few cents. And if those cents are controlled well enough, repeated enough times, across enough orders, they become a serious business. That is the secret business of clothing factories.